I chose this week's case really for four reasons. First of all, it's just an interesting case. It's an interesting problem. In fact, I was once talking with a student about this very problem, and it just so happens that a member of our board of visitors was overhearing me and so wanted to talk to me about this particular problem. But it's really just, it's fascinating because we often think of AI as being something that exists really more in this digital world and kind of in, in kind of white collar positions. But here's an example of where you had something that's really a certain form of waste management, also really finding a very useful case for artificial intelligence. So the interestingness of the problem was one reason. And then there were a couple of artificial intelligence concepts really that I wanted you to get out of this. One is just that so we're talking about deep learning this week, and there are really two major categories of deep learning. One had to do with convolutional neural networks, that is the modeling technology that enables computer vision. So being able to look at images and to understand what is actually in that image. So this is enabled by convolutional neural networks. The other one, as you recall, is recurrent neural networks, which allows us to model sequences, so things like language and audio streams. Now, lately, recurrent neural networks have been replaced, superseded by transformers. In fact, the T in ChatGPT is transformer. And the reason there's a transformer there is because it's a sequence. Language is a sequence that is modeled with something like a recurrent neural network, except a different architecture, which is called a transformer. And we'll talk about that more with the unit on generative AI. So it's this idea of computer vision. And then also the notion of transfer learning, which is a pretty important concept in training. Training is often the most expensive part of developing an AI model, and transfer learning is a great way to shortcut that. And then finally, it has an interesting evolution of the business model, in particular going from selling software as a service to selling hardware. And we'll talk about that just a little bit. All right, so the key point here is what's going on here is recycling became no longer cost feasible for a lot of municipalities. And the reason for that is because there was no longer a market overseas for a lot of the kinds of recycling that was being done. So historically, they've been able to sell the recycling to China. But China changed its policies and developed this policy, so-called the national sword policy, where they raised the standards of what they were purchasing from overseas because they wanted to support their own recycling industry. So what this means is that now, in order to revive and make cost-effective again the entire recycling industry, they had to have some way of maintaining these purity standards or really cleaning it up. If you have people doing the sorting, then it becomes too expensive and there's no point in even doing it. So what this solution is it's creating a machine that can do the sorting for you. So it's applying these convolutional neural networks to computer vision. So they sell these cameras that can, or they lease these cameras that can just watch a conveyor belt and classify what is actually on there. Now, in order to do this, of course, they had to train these classification models, and they did it they manually tagged 5,000 images for what was in there, and then that was one part of it. Now, the other part is this tagging, this customized training, was built on top of a more general purpose kind of image classification training. So they took these existing models that know how to do object recognition and image processing, and so I looked up what some of these are. So they're you start off with like a base object classification model like ResNet, MobileNet, YOLO, VIT, Hugging Face, and there's some in TensorFlow also. And then on top of those, you retrain those. You adjust the weights of those training models according to new data that you train on. So you're taking the learning that was obtained in the general purpose training and then transferring it over to the specific problem of classifying recyclable waste. Okay, so that's an example of transfer learning. One way you can think of transfer learning is so if you were to, let's say you wanted to learn Italian, but at some point in the past you had learned Spanish. So it's going to be far easier for you to pick up Italian if at some point in the past you have trained your internal neural network on Spanish, because you can take what you learned when you learned Spanish and apply it over to the Italian. Well, transfer learning in AI is similar to this, where you've got these trained neural networks that have kind of a base set of training, and then you build training on top of that. So this was a really interesting instance of this, where they were able to save a lot of money from that would have been required, a lot of compute and a lot of time, a lot of data, that to start off with their own visual classifier, they were able to use existing ones and build on top of it. Okay, so the other thing I mentioned was the evolution of the business model. So they started off just by having these cameras and then selling or leasing software as a service, where people pay a subscription to get this, these images are taken from these cameras and they're sent up to a server that does the classification and then builds a kind of a visualization for the facility managers to use. But this turned out to not be, a very good business model over time. So what they did was they started changing how they did this, and they made custom hardware that had embedded in it the software that would be used for the classification. Software runs faster when you can build custom hardware for it to run on. So they sold these hardware devices that would go, and so it'd be like a one-time purchase, and you would put that on, and that would do your classification for you. So moving from a subscription model to actually selling a product. Okay, and so so of course the priorities are, these facilities needed these custom AI models. There are a lot of different facilities, so the company wanted to be able to scale, to build these things and send them out, and would of course maintain those critical aspects: safety, speed, and model performance. So in the discussions this week, there were a lot of people with some really interesting ideas about computer vision in general, and then also about transfer learning. So, for example, this idea of using AI to monitor emergency scanner channels. So processing audio is something that a recurrent neural network or transformer does very well. So then taking these transmissions and then using natural language processing to flag important key terms, and then pushing that information over to Microsoft Teams, which is where then a human gets involved and can start reading this and maybe determine what are important things to investigate. There was also an example of actually transfer learning on higher education. So the task is curriculum alignment. That is, making sure that the stated learning outcomes of the class are what is actually being taught and assessed. Or at the program level also, what are the essential competencies of this program, and how are those being assessed in the long term? So just making sure that what the goal is actually matching what's actually being done. And so the idea here was to take existing tools for classification and then putting them for classifying the various things that need to be classified for this particular use, which is curriculum alignment. There's also an idea of K-12 education where the need was for lesson planning and student interventions and language assistant and special ed services, and the idea there was to take pre-trained AI programs, so again these general purpose base models that are made for just schools in general, and then build them or adopt them into the school with the idea that sometime down the road there might be a way to enhance those, use that transfer learning to build in something more specific for the school. And then a computer vision application that I thought was kind of neat, using a computer vision to monitor drive-through traffic and update, forecasts of customers and, communicate what needs to be communicated in terms of inventory and cooking. So those are some ideas in general. So the themes that I saw emerging either explicitly or implicitly kind of around the edges this week. I see a lot of systems thinking. That is, AI is embedded in workflows and not isolated tools. So I really like it when people mention, here's my work and here's what we do and here are the challenges and let me talk about how this can actually work for me. I have found that the people who do that tend to do better on the project because they're, I don't know your work as well as you do, so I can't really state whether what you're saying about AI is going to make sense. But if you make that case, if you go into those details and tell me about what it is that you do and where the pain points are, I'm in a better position to actually assess whether AI is the right tool there. So a lot of people thinking about like resource-based thinking. So remember the resource-based view. There are a lot of organizations that are just very constrained in what they have, what they can do. Pie in the sky kinds of things are just not really worth the investment. But I will say that now resources are far less constrained than they used to be. In the last few years, a lot of things have gotten free or inexpensive, and so it's opening up opportunities that didn't used to exist. So the reluctance to adopt, there's really less justification for that now than there used to be. So, of course, realistic risk assessment. So some of you work in highly sensitive areas, so Department of War and so forth. And so the main concern, and this is a concern, especially with these new, of course, these free web-based LLMs, AI agents that are created with open source tools. These are a real privacy, data security issue waiting to happen. And so there are some people who just said, look, given given the realities of my position, this is just not something that really we can't just plunge into this, and that's totally totally fine. Definitely a good reason to not do it. And of course, always focus on mission alignment. That is, some people are in business as student support. Some people, newsrooms have to be very productive now. The staff is getting smaller and smaller. So really, lots of great thinking about what is it that we actually do here, and make sure that any kind of technology adoption that we have is going to serve those larger purposes. And so as part of this kind of like identifying what we are, who we do, and what our resource constraints are, there's this idea of anything that we do is going to have to be layered on top. So we already have IT infrastructure, we already have our databases. In some cases, some people already have a pretty sophisticated portfolio of AI agents, and so anything that they do now is going to have to go on top of those. And consequently, there's good things and bad things. Those lots of resources are already there, but that means any changes are going to take a lot longer. This is my experience talking. The more complex an existing system is, the harder it is to make any new additions and changes. And this is partly also why larger companies tend to be less agile than smaller companies. Okay. All right. So that was a really interesting week, I thought. It's possible that next semester I'm going to just drop the deep learning unit and just because we need to talk about agentic AI, and I might just drop the deep learning and put the agentic in this place anyway. So next week we're going to be talking about robotics, and these tend to be the funnest and kind of most pie in the sky kind of things. But I encourage you to be creative about where robotics can work into your organization.